There we go. Day 2 of sine and cosine graphs. We are starting off here by writing an equation of a cosine graph whose amplitude and period length would fall in between the amplitude and period length for the two graphs shown. So a little bit different. I just wanted you to look at it a little bit differently and have to think your way through it. Let's see how we did. Amplitude, period length, amplitude, and period length. And so the whole key here is just identifying that first. So that's part of this thing, is being able to look at it and identify. As we look at that first one, Megan K., what do you think the amplitude of that first graph is? Yeah, 1.8-ish. Yeah, I'm good with that. And who knows? Maybe it's 1.75. Maybe it's 1.9. Who cares? It's somewhere in that ballpark. Good. That's my amplitude. What about period length? Anybody have a good guess on period length? 7. I disagree with that. So this is. Tell me when I've hit a full period length. All right. Tell me when I've reached. Let me do a different color besides red. Tell me when I've reached a full period length here. Right there. Okay, so somewhere between pi and 5 pi over 4. You agree with me on that? First period, they said it was 1 pi and 1/8 pi, or in other words, 9 pi over 8. That's what they said. It doesn't matter. We just know that it's somewhere in that land. Okay, somewhere to the right of pi. Let's do the next one. Same idea. Ella, what's my amplitude of my second graph here? Yeah, 2.8. That's great. 2.8. Period length. Let's play the same game. Tell me now when I've reached a full period length. Stop right there. So, like, right in there. Ugh, something between 3 pi over 2 and 7 pi over 4. Don't all shout out an answer at once. So it would be how many pi over 8? Oh, 13 pi over 8. Oh, that's garbage. But that's all right. That's my answer. So this one is at 3 pi, or whatever that thing is. And this one was right in about here. So my period length needs to fall into that place somewhere. Yes, ma'am. It is, but that's not going to really affect me at all. The amplitude being positive or negative, that's not really, that's more of a flip concept. But yes, I agree with you. The second graph is definitely flipped. All right, so we've got that set up. Now we are going to write an equation. So our equation is going to be y is equal to something. They did ask us to do cosine. So something cosine of something x. Because that's how I change, this is how I change my amplitude. This is how I change my period length. What number would be a great number to go in front? 2, because 2 falls in between 1.8 and 2.8. Yep, we good. Period length. What would be a good period length to happen here if this is that one and that one's that one? 3 pi over 2. Everybody agree that 3 pi over 2 would definitely fall in between these two lines? Yeah, 3 pi over 2. Okay, so I want my period length to be 3 pi over 2. So do I just write 3 pi over 2 right here? No, because to get period length, we start off with our base period length, and then we multiply by the reciprocal of whatever's in front of my x. And I'm trying to get an answer of 3 pi over 2. So thoughts on what I could do to solve here? Matthew, if I want to get this thing right here by itself, what do I got to do? I want to get rid of this times 2 pi. How do I get rid of times 2 pi? If it's multiplied, the opposite of multiplying is dividing. Yeah, we're going to divide by 2 pi. Or in other words, multiply by 1 over 2 pi. That's going to cancel. These pi's are going to cancel. I get this something over here is equal to 3/4. So do I just write 3/4 right here? No. I want to write the reciprocal because this is what I'm multiplying by. This is going to be 4/3. Okay, and if you want to check your work, we easily could. We would take 2 pi, and then we would multiply by the reciprocal of whatever's in front of my x. I get 6 pi over 4. Yeah, that's 3 pi over 2. which is what we were looking for the whole time. That's a weird problem. Don't let that weirdness throw you off. I just wanted you to think about amplitude. I wanted to think about how you solve for period length. We did both of those things in that problem. Kind of makes sense? All right. So today, second day, we are doing translations of sine and cosine graphs. So yesterday we stretched them. We went vertically stretched and horizontally stretched. Today we're going to shift them as well. So we're going to shift up and down, left and right. Let's talk about some of these things. The A in front, what does that A in front represent? That's our amplitude. And what does it do to our graph? Vertical stretch. Great. Then we had this little omega guy. Okay. Notice today that I used theta throughout the notes. That's fine. Theta, x, they mean the same thing. Don't get thrown off just because it says theta there. Okay. The omega, the thing multiplied by your x, or in this case, in front of my theta, what is that going to do to my graph? That is a horizontal shift. It's going to change my period length, yes. It's not my period length. It's going to change my period length. Great. Then I've got this guy right here. Something added or subtracted inside of parentheses with my x. If I add or subtract something inside of parentheses with my x, what is that going to do to my graph? It is a horizontal shift. And I like somebody said it. What else do I have to think about when I do horizontal shifts? Do the opposite. Okay, think it's been a minute since we've done it, but think back to when we did like x minus 2 squared plus 3. That's a parabola. This minus 2, it says minus 2, and that really takes me to the right 2. Yes, ma'am. I did. Yep, my fault. Thank you. This is supposed to be horizontal stretch. My apologies. Horizontal stretch. I was saying it in my brain and wrote shift because I was thinking about the next one. This one is a horizontal shift. And then the plus k, the thing tagged on the outside. What is that thing on the outside going to do? A vertical shift. We do what it says. So if it says plus 3, then we go up 3. If it says minus 3, then we go down 3. All that good stuff. Questions here? Let's put it into practice. I got to adjust here a little bit. But phase shift. That is a phrase we are going to use more later on. Okay? Technically, a phase shift makes it pretty difficult. A phase shift is when you change the period length and have a horizontal shift at the same time. They are not fun to graph. So we are not going to graph those very often at all. Okay, so when you hear that word phase shift, just think, oh, that means horizontal shift, okay, for what we're doing today. So we're going to state the phase shift or the horizontal shift for each function, then graph it. Okay, so we're going to do the same thing we did yesterday. We're going to start off here. We're going to talk about the amplitude, the period length. Then we can talk about the horizontal shift and the vertical shift. Those are the two things we're adding today. Amplitude, period length, horizontal shift, vertical shift. That's what we got. Here's my equation. What's my amplitude going to be? 1. There's nothing in front. My amplitude is 1. Period length. We start off with our base period length. It's 2 pi. Is that going to change here? Nah. It's just theta. There's nothing in front of my theta, nothing in front of my x, so it didn't stretch me horizontally at all. Horizontal shift. Do I have a horizontal shift here? Yes, I've added or subtracted something inside the parentheses. I've got pi. You need to also state a direction, whether you draw an arrow or you write the line, point, which way are we going to go pi? If it's minus, we are going to the right pi. Vertical shift. Is there something tagged on the end that is going to move me up and down? No. So we don't have that. Now that we've got that information, we're going to graph it. Okay, so I'm going to make my x-axis or my y-axis and my x-axis. I'm going to use my brain here. Okay, before I make my x-axis and my y-axis, I'm going to think, oh, hey, I've got a horizontal shift to the right pi, which means my graph is going to be stretched to the right quite a bit, or moved to the right quite a bit. So I'm going to draw my graph. I'm going to make it pretty long here on the right side. I'd rather give myself space and not use it than have to try to cram everything in. Okay, there's my graph. Then next thing I'm going to do, so I make my x-axis, y-axis. Then I'm going to label my period length. So I'm going to make my 4 hash marks. 1, 2, 3, 4. I'm calling this guy right here 2 pi because my period length is 2 pi. So since my period length is 2 pi, I make that 2 pi. If that's 2 pi, then my second hash mark is going to be pi. If that one's pi, then my first one's going to be pi over 2. And then it's 1 half, 2 halves, 3 halves, 3 pi over 2, and 2 pi. So first thing we did didn't change from yesterday. We did that. Okay. The next thing we were going to do, just like yesterday, was make our amplitude. Okay. So how much am I stretching vertically from my x-axis? Just 1. And so I'm gonna go up 1. I'm gonna do 2 do 2 boxes on my grid, just so I don't have to stretch everything together, to smash it together. It'd be hard to see. Okay. I'm gonna spread it out a little bit. That's why we label stuff, so you can stretch your graph and make it fit and be able to be visible without anything else. The labels are the most important part that we do on any of this. Again, this is my top line, so I'm going to draw a little dashed line here. You don't have to draw the dashed line. I just like it because it keeps me organized. There's the bottom line. Now we're going to graph it. It is a cosine curve. So if I'm graphing cosine, where am I going to start? Top, middle, or bottom? Top. Normally, I would put a dot right here, but I'm not going to put a dot right there. Why not? It moved over. We shifted to the right pi. Okay? So how many hash marks do I need to move if I'm going to the right pi? 2, because look at your label. Hey, there's pi. I need to go to the right 2. That is where my new starting dot is going to go. And if I move to the right 2 pi, I'm going to add 2 more hash marks to the right side because I need to continue to draw a full period length. Okay, so 1, 2, 3, 1, 2, 3. I could call this, what would this one be labeled as, this last one? 3 pi, because I went 2 pi, added a pi to it. You don't have to get crazy on labeling those, but you can. It's easy. That's 3 pi. Okay, we're at the top. Then we're going to go top. Then my next one, I'm going in the middle, bottom, middle, top. I'm going to connect those dots. I'm always going to make you just draw 1 period length. Even on your homework, I think I said draw 2 cycles. Just do 1. That's perfectly fine. Okay, 1 cycle is plenty. But that is my graph. You can do more than 1 cycle. I'm okay with that. But you need to have at least 1 full cycle. So some of you might have done this and started your graph down there. That's fine. As long as you have a full cycle. Okay, if you would have graphed just this, that's a full cycle. Just as long as you have 1 full cycle, 1 full period length graph. Questions on the first one? Try the second one. -4 sine, theta plus pi over 2. See what you can do with your neighbor. Go. Amplitude. Lydia, what's your amplitude going to be? It is 4. What else do we have to think about when we see that 4? It's negative, so we're going to flip it. So make sure we write flip somewhere so we don't forget. Amplitude is 4, though. Period length. Kendall, what's my period length going to be? 2 pi. Nothing changed that. Vertical shift, yes or no on this one? Nah, nothing added on the end. We haven't done those yet. And then horizontal shift. Eli, which way am I shifting? I'm shifting left, pi over 2. It's plus pi over 2, so we're shifting left, pi over 2. Let's put that on a graph. I'm going to be smart about how this works. The amplitude is 4, so I need to stretch quite a bit. So I want to make sure I have a big enough y-axis. And I'm shifting left pi over 2, so I want to have enough space over here on the left side. Enough space over there on the left side to be able to do that. Make my 4 hash marks. 1, 2, 3, 4. There's my 4 hash marks. This guy's 2 pi. This guy's pi. Pi over 2, 3 pi over 2. Once I've done that, then I'm going to do my amplitude. So my amplitude is 4. So we're going to go up 1, 2, 3, 4, label it. Down 1, 2, 3, 4, label it. That is the top of my graph. That is the bottom of my graph. Next thing I'm going to do is graph. It is a sine curve. Where am I going to start? Top, middle, or bottom? middle, but it's flipped. So where am I really going to start? Still in the middle. That doesn't change anything on a sine curve. But that's not going to go there either. What else do I need to do? Shift left pi over 2. So how many hash marks do I need to make here to the left-hand side? 1, because we said that 1 hash mark represents pi over 2. So I'm going to make a new hash mark over here to the left, 1 right there, and call it negative pi over 2. So that is where I'm going to make my first dot. The one thing that students do poorly is this next thing. I started in the middle. Now I'm going to go where? Down, because it's flipped. And then every once in a while, student will skip. Where at what x value is my next dot going to go? At 0. It's going to go on the y-axis. Okay, every once in a while, a student will jump all the way over to pi over 2. Don't skip it. It'll look funky on your paper. Okay, but I'm there, and then top, and then middle, and then connect those dots. Questions on that sine curve? Okay. Let's go next one. Okay, we're adding a new phrase here, the principal axis. You will not hear me call it the principal axis very often, but it is the principal axis. The principal axis is the middle line of your graph. It's the line that would split it right down the middle. Okay, we won't use principal axis. The phrase we will use is midline. Okay, the textbook uses principal axis a little bit. It's the midline. It's the line in the middle. Don't overthink it. We haven't had to really deal with that yet because for every graph we've done, what's my midline been? 0. It's been the x-axis. Okay, now that's going to change a little bit. Let's see what we can do. Okay, so number 3, we're going to start off the same way. Amplitude, period length, vertical shift, horizontal shift. Amplitude here. Kate, what's my amplitude going to be? 3. Period length, Sam McCain, what's my base period length going to be? 2 pi. But it's not going to stay 2 pi. I need to multiply that by the reciprocal of whatever's in front of my x. So what do you need to multiply by here? Yeah, we can just deal with 1/3. We don't have to mess with the negative, but yes, 1/3. Okay, so we're going to multiply by 1/3. Yucky. My period length is 2 pi over 3. Okay, this is good fraction practice for us. You're not always going to have to graph sine graphs in your job. Okay, but understanding fractions a little bit better, that is something you might have to do a little bit more of. So that's why we're doing it more than anything else. Horizontal shift. Do I have one of those? Nothing added or subtracted inside of parentheses, so no. And then, no, that's horizontal shift. Sorry. Vertical shift. Do I have one of those? Yeah, this plus 2. It's tagged on the outside. It is not inside of parentheses, so that 2 is going to take me up 2. What is something that I didn't put down here? What is something that we forgot? The negative sign. What does that negative sign right there do to my graph? It flips us horizontally. And if we think about that, it's kind of tough. Okay, it is going to flip us horizontally over the y-axis. But we can also use something else to help us out here. Sine x. Here's sine x. Everybody see it? Here is sine of negative x. See how we flipped it horizontally? We took this point and flipped it over to make it there. And we took this point and flipped it over to make it there. Does that make sense? Or the better way of doing it is using the even-odd properties. Okay? If we're doing sine of negative x, what is that the exact same thing as? Negative sine of x. Oh yeah, the same thing. You could deal with this one, but it's just going to be weird to you. It is much better to take that negative sign and say, hey, that's the same thing as a vertical flip. Know why these are called even-odd identities. Okay, remember even and odd, those words that we used a long time ago? An odd function means it has origin symmetry. Or in other words, if I took this shape right here and I flipped it over and down, it would match up. A sine curve is even. I'm sorry, a sine curve is odd. It's got origin symmetry. What about a cosine graph? Here's cosine x. Okay, if I flipped that thing horizontally, what happens if I flip that horizontally? Nothing. It's the same. That's why when we deal with cosine with a negative, it can just disappear and not bother us at all. Does that make sense? What type of graph is a cosine graph? Is it even or odd? It's even, because remember that means you can fold it over the y-axis. It'd be an even graph. That's why the negative sign doesn't matter. All right, let's put it on here. I'm going to be smart about my graph. I'm vertically shifting up too. So when I make my x-axis and my y-axis, I'm going to make it so that my x-axis is down here a little bit because I need to shift it up too to make it fit my picture. Okay, just like before, I'm going to make my 4 hash marks. 1, 2, 3, 4. I'm going to label this 4th hash mark as 2 pi over 3. If this one's 2 pi over 3 and this one right here is half of that, what is half of 2 pi over 3? 1 pi over 3. If this is 1 pi over 3 and this is half of that, what is half of pi over 3? Pi over 6. Just think about what we're doing. If we're cutting it in half, it's like multiplying by a half. If you multiply that together, oh yeah, that gets me pi over 6. What is this third line going to be? It is pi over 2 because it is 3 of these guys. 3 of pi over 6. So if you had 3 pi over 6, oh yeah, that's pi over 2. It's good fraction work more than anything else. Okay, if there's only one thing you get out of today, maybe it's being a little bit better at fractions, and that'll help you in a lot of different ways. Vertical shift. So normally next we would do the amplitude, but here we're going to change a little bit, and the next thing we're going to do is the vertical shift. If you have a vertical shift, that's the next thing we're going to do. So we're going to make our midline. So I'm going to go right here to 2, and I'm going to draw a middle line on this graph. That is the midline. It is the center of my graph. If that is the middle of my graph, once I've done that, so boom, did that. I've done this. Next thing I'm going to do is amplitude. If I'm doing amplitude, that is the stretch from the midline. So where do you think the top of my graph is going to be? The top of my graph is going to be at 5 because I'm going up 1, 2, 3. I'm up here to 5. That is the top of my graph. Where do you think the bottom of my graph is going to be? -1. I'm going down 1, 2, 3, down here to -1. That is the bottom of my graph. Great. I've done all of that. Now I can do my actual part here, which is a sine graph. I forgot. I talked about this negative sign. I never did anything about it. So what's that negative sign going to do to my graph? It's going to flip me. Yeah, it's going to flip. So don't forget about that. Make sure you've written that word flip. I almost forgot it as I did it. It's a sine curve. So where am I starting? Top, middle, or bottom? Middle. But it's flipped. So where am I actually going to start? Still in the middle because it's in the middle. But I flipped it. So the next thing I'm going to do is go down. Go all the way to the bottom. Don't stop on the x-axis. Go all the way to my bottom line. And then I'm going to go to the middle line. Top. Middle. Connect the dots. There's my graph. Questions there? I used to make my students graph these, and I didn't give them graph paper. They were ugly. So be happy that I did it. I kind of like graphing on graph paper. It makes me feel good inside. Try the next one. Try number 4 here. Here we go. Amplitude. Evan, what do you say on amplitude here? 2? Good. Period length. Abby, what do you think on period length here? Yeah, we're going to start with 2 pi and then multiply by the reciprocal, 3 over 2, and that is going to get me 3 pi. Good. Then we're doing vertical shift. Do I have a vertical shift here? Yeah, we do. What's the vertical shift? Down 3. How do we know that this is a vertical shift and not a horizontal shift? If it were in parentheses, if it were grouped with my x, then yes, it's a horizontal shift. That didn't happen. So that is a vertical shift. I probably should have thrown parentheses around that. That's a little ugly to me. But yeah, it's not a vertical shift. And then the horizontal shift is a no. What else do I need here that I didn't put? It is flipped. I've got a negative sign here in the front. Don't forget to write flip, otherwise we'll forget it. Let's graph it. I'm being vertically shifted down 3, so I'm going to put a whole lot more underneath my x-axis than above it. Boom. This guy is 3 pi. If that guy is 3 pi. Megan, see, what's this one going to be called? Good. If that's 3 pi over 2, what's this one going to be called? Remember, it's just like dividing by 2 or multiplying by a half. So what's the bottom going to be then? Yeah, just 3 pi over 4. This is, remember, it's just like multiplying the denominator basically by 2 because you're cutting it in half. So it's 3 pi over 4. This is 3 pi over 4. This is 6 pi over 4. This would be 9 pi over 4. In other words, 3 times whatever was that first one. We've done that. Once I've done that, Kara, what am I going to do on here next? Find the middle. Good. Where's my midline going to be? Yep, that's my midline right there at -3. So she can go ahead and draw her midline here at -3. Herman, what do I do next? Amplitude. So where's my top line going to be? -1 because her amplitude is 2. So she went up 2 from her midline, drew the top, and then you're going to go down to where? -5 because she's going to go down 2 from that midline. There's the bottom. Okay, top, middle, and bottom, making sure we understand that. Okay, this is like elementary writing. Okay, think about when you learned how to make your letters. Okay, your letters are going to go in between these lines, and this goes in the middle, and I don't know what word I'm writing, but it's going to fit in there. I don't know why level was the word, but I thought it was a good word there. All right, now let's graph. If I'm graphing this thing, Max, where am I going to start? Top, middle, or bottom? The bottom. Why the bottom? Negative cosine. So we start at the bottom, and then we go middle, and then we go top, and then we go middle, and then we go bottom. Be careful. You're going to want to not go to the top, middle, and bottom. Did you do the ultimate sin here of going outside? Because that would make me cry inside. Don't do that. Stay in between. Bend back towards the other one. Questions there on 4? Show me with your fingers how you doing. 0's bad. 5's great. 0 to 5, where are you? Okay. We'll keep getting better. We're 3's and a half, 4's great. We're going to keep getting a little bit better for the most part. Stay with me. Okay, go to the backside. On the backside, I just kind of wrote out the order of operations here in terms of what you should do. First thing we're going to do is label the period length. Then we draw our midline. Then we're going to do our stretching, our amplitude. Then we can do the horizontal shift, and then we can graph it. That's kind of the order that you need to follow. So if you're not great at this yet, that's what we're going to follow. Okay? I want to get a couple in here, but I want to go fast. So let's do it. Amplitude, period length, vertical shift, horizontal shift. You got 1 minute. See what you can do with it. Amplitude. Lydia, what did you say for amplitude? 2. What about your period length? 2 pi. That did not change. We're done in front of a theta. Vertical shift. Matthew, what did you say on vertical shift? Up 3. What about horizontal shift? Left pi. Good. Left pi. So pi with an arrow of some sort. We got that. That was our first thing. Next thing we're doing is labeling our axis. So boom, 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 boom. This is 2 pi. So we should be pretty good with this one. That's 2 pi. So this is 1 pi. This is pi over 2. This is 3 pi over 2. Next thing we're doing is midline. So Sam K, where's my midline going to be? At 3. That's the middle line. Sam, what? So then I'm doing amplitude. I drew my midline. I'm going to label it 3. Where's your top line going to be? At 5, because her amplitude is 2, so she's going all the way up to 5. Where's your bottom line going to be? At 1. Good. So my line, or my graph, is going to live in between these 2 sets of lines. So we did period length, we did midline, we did amplitude. Now we're on horizontal shift. Okay. This graph, it is a cosine graph. So normally I would start at the top, but it's not going to go there. Okay. I'm horizontally shifted to the left pi. So how many hash marks do I need to go to make the left pi? 2, because 1, 2. That's how far I went left. So that's how, or to the right, that's how far I got to go to the left. 1, 2. I'm going to call that negative pi. That would be negative pi over 2. I'm doing a cosine graph, so where am I going to start? Top, middle, or bottom? Start at the top. Top, middle, bottom, middle, top. Connect the dots. There's my graph. These are the worst case scenario. If you can do these on notes, then you're going to be good on everything. All right, I'm making them hard. This one's not the hardest, but like the last one was pretty tough, and the next one's pretty tough. If you can do these, you should be good. Questions there? Next one, give you about a minute. Go. There we go. Amplitude is 3. Period length, we start off with 2 pi, and then we multiply by the reciprocal, so it's really 4 pi. My vertical shift is down 2. My horizontal shift is no. What about the negative signs here? They cancel out? We've got two things going. We've got a vertical shift. We've got a horizontal shift. So understand what that would look like. Okay, if I had this graph right here, okay, that's what sine of x looks like. Here's what negative sine of x looks like. We flip it over that way. But if I then put a negative sign right there, it's going to flip it back again. Two negative signs just cancel us out. Okay, we know that if you have a sine with a negative curve, that's going to go out in front and would work to there. Okay, then we're going to label it. This is 4 pi, so this is 2 pi, this is pi, this is 3 pi over 2. No, just plain, just 3 pi. Then I'm doing midline. My midline is down 2. That's my midline, negative 2. My amplitude, where's the top line going to be? It's at 1. Because I'm going up 3 from the middle. I'm going down 3 from the middle. So I'm down here at negative 5. Make sure you are labeling those. It is a sine curve. So if I do a sine curve, where am I going to start? Middle, and then top. Go all the way to the top. Don't stop at the x-axis. And then middle, and then bottom, and then back to the middle again. There's my sine curve. Good there? Last one. Stay with me here. Okay? Amplitude, period length, vertical shift, horizontal shift. Amplitude is 2. Period length is 2 pi. Vertical shift is down 1. What about horizontal shift here? It is pi over 2, but which direction does it need to go? To the left. It's been a minute since we've done this, but remember, if it's negative x minus pi over 2, you have a negative in front of that x. Remember back in August, we factored that thing out, and it's really a plus pi over 2. That negative mattered in terms of moving me to the left. What is this negative going to do if it's a cosine graph and I have a negative inside the parentheses? Nothing. It's not going to flip me. It changed how I shifted, but it didn't change anything else. That negative is not going to flip my graph at all. Does that kind of make sense with that guy? I'm going to graph it just super quick here so we can see it. So 1, 2, 3, 4. This guy's 2 pi, pi, and so on. Down 1 is my midline. Amplitude is 2, so I'm going up 2 and down 2. I am shifting to the left pi over 2, so I'm right here at pi over 2. It is a cosine graph, so I'm going to start down here at the bottom, and then go middle, and then go top, and then go middle, and then go bottom. There's my graph. No, I don't know why I started at the bottom. Just kidding. That's what I get for going quickly. That's my graph. Questions with what we did today? You'll get better. It's just a matter of practicing.